how big data is processed using Hive. So Hive is a technology or a processing mechanism by which we would be processing data stored in SDFS, or I can say Hadoop mechanisms. So before we start, a small introduction about myself. My name is Sandeep Agarwal. I'm the trainer for BigData Hadoop for the company Kratos. I am also undertaking a lot of other training assignments pan-India basis, and I have got more than 18 years of IT experience and a couple of years experience in Hadoop and Big Data. And I've taken more than about, you can say, I've trained more than 3,000 people up till now, beginning from freshers to having 20 years of experience in IT industry. So let us begin about this journey about big data. It's a very exciting journey. Initially, I'll be giving a small introduction to big data, the challenges of big data, introduction to Hadoop. Then we'll be moving on to Hive history, who has created Hive and what is Hive. I'll be talking about some of the features of Hive, the components and the architecture, and finally we'll be going through the operations of Hive, where we'll be dealing with the Hive commands. So you guys must have heard about and read about a lot about big data, what is big data and how it is useful in the day-to-day activities of getting insights of any kind of information which you would like to draw from the data analysis by using various tools like available. And in this case, we'll be using Hadoop as a framework where we'll be pulling all our data into Hadoop framework and processing it. So big data is nothing but any amount of data which runs into terabytes or petabytes can be termed as big data. Sometimes we also understand that the data may not be large, but the generation of speed, the speed at which data is getting generated may be very, very large. Maybe in that case, even that data can be termed as big data. So the data which is being generated at a very high speed, certain examples can be called from stock market data coming from stock market exchanges, or you can say weather station data, data coming from machine sensors, and so on. So where you have streaming data being produced, and that data needs to be captured, processed, analyzed, and finally get some valuable insight from that data. And the data could be of any sizes or any structure. Initially, we say that it's very large and complex. So the word complex stands for data coming from various sources. Initially, we talk about structured data coming from RDBMSs. We also talk about unstructured data coming from your social network environment. Plus, we also have a third category of data, which is semi-structured. The data which is stored in XML files and JSON files can be termed as semi-structured data. So what happens in a traditional mechanism, if I had different types of data, I would need to convert all the data into one type. For example, there are various ETL tools available. If I am pulling some unstructured data, I first need to convert them into a structural mechanism before I start using that data for some processing. So in the case of Hadoop mechanism, I don't need any ETL tools. A framework allows me to capture and process all types of data under one umbrella. So I don't have to use any of those tools to first convert them into any common data type. So that's why it says any data sets which are large and complex that becomes difficult to process using on-hand database management tools or any traditional data processing applications. So whatever data is available today in the domain, all data can be processed under one framework. And that is the biggest challenge we are facing today. And for that purpose, we have this framework called Hadoop. The challenges also include how do we capture this huge amount of data. Remember, data running into petabytes and exabytes. That cannot be stored on one single machine or one single server. So how do we store this huge amount of data into a mechanism so that we can capture it, store it, and do some search analysis, and then finally we can visualize that reports coming out of that data. Who is generating all this big data? We all understand the huge amount of data is being generated today by social media network. All your WhatsApp, Facebook, Twitters, Google email bodies, these all come under unstructured category of data. We have more number of mobiles or telephones available on this earth than the people. So all these mobiles and apps which are running on those mobiles, they are also becoming huge amount of data generators. Plus we have other mechanisms like your machine sensor, ATM, scientific instruments. Plus apart from that we have standard data generation like all your structural databases where you are storing a lot of information. So these are all different sources of generating data. And when we combine all this data, it falls into the category of big data. Remember, all this data earlier was not getting generated too much. It is only happening in last couple of years. So there's a boom of huge amount of data being generated, and one needs to capture it, store it, process it, and get some valuable insight. One more thing to note, the larger amount of the larger share of this big data is borne by the unstructured data, and mainly it is coming from social media network. And the life cycle of this data is very, very short. Today what we are thinking, tomorrow 2 months down the line, we may not be thinking that way. So in that case we need to store that all amount of data, and that data could be running into petabytes because every day we generate huge amount of data. So we need a mechanism by which we can run neck to neck at the generation of the data, capture the data, process it, and then get some valuable insight. Now you must be wondering what valuable insight one can draw from social network media. Certainly all of us are now using different applications, and knowingly or unknowingly we are sharing all our thoughts through that medium. Earlier we were using a verbal communication mechanism by which we were sharing our thoughts, but now everything we are sharing our thoughts, it is digitalized. So everything is on the record. Now somebody is using that data and processing it to get some valuable insight. So all the companies which we are sharing across the data, for example, we have Facebook, we have WhatsApp, Twitter. These companies, they store all the data, whatever data we are sharing across, and they are selling to the beneficiary of the user. It could be a product manufacturer, it could be a service provider, or it could be many different political groups across the world. So every citizen is sharing their views on the digital format, and that digital format is processed. Whatever data is there is processed and then shared across, and that is how these digital companies are minting money or making money through the valuable analysis. So today we have become a sort of a data generator. We are generating this huge amount of data, and there need a mechanism by which you can process all this data into valuable insight. Now this slide will tell you exactly the growth of unstructured data. The blue shaded part of your bar graph is basically the unstructured one. The red one is your structured data. Now just see the growth in last decade. The growth of unstructured data is very, very phenomenal, and that is mainly because of social network, where all the people across every part of the world are interacting and sharing their likes and dislikes and views across the digital platform. So this is now becoming a boon, or you can say a source of understanding the buyer or as a human, what are the likes, dislikes, and what they would like to wear, eat, where do they like to go for a vacation. So all that information which is being stored can be analyzed and then can be passed on or sold to the beneficiary of that particular information. It could be anybody. And this data is specifically people are targeting the unstructured one, which needs to be captured, manipulated, extracted vital information, because a lot of business decisions are being made upon after analyzing this data. Even people are now deciding in which locality a retail company would like to open their store basis upon the feedback they receive from the social media, because this gives them a lot of understanding about the buyers, their own buyers, and accordingly they can decide where do they would like to open a new store, in which locality, which will give them a huge amount of business. Other examples could be about a company which has been dealing in some products, and they're getting proper feedback, so that as per the feedback they can modify their products or rectify their own services in whichever field they are. So one data they would be having their own sales data, and one data would be their social media data. Now they can compare both the data and they can analyze, okay, now why the sales are going down and what is the proper feedback, so that accordingly they can fine-tune their products or services. So the life cycle of this unstructured data is very, very short. Please understand that is the need. We need to capture it, we need to store it as early as possible and process it to get the valuable insight. Now what is this mechanism Hadoop which will solve these issues? Remember, earlier big data was a problem, but today big data is considered as an opportunity. Why it is an opportunity? Because we have a framework by which we can process any amount of data and get the valuable insight. Earlier, people were not knowing what to do with this data. They were discarding it, or they were just leaving it aside because they had no clue what to do with this data. But now, with the advent of this framework, I can process any amount of data. Could be exabytes, petabytes, any amount of data. There is no limit to it. So there is such framework which can store and process any amount of data, and that too in very quick time. What is Hadoop? Hadoop is a framework that allows you to store and process large data sets across clusters of commodity computing using simple programming mode. Now when I talk about Hadoop, Hadoop is not a single machine. It is not made up of single machines or two machines or three machines. When I'm creating a framework, basically I'm creating a network of multiple machines, and then storing my data in blocks, in chunks across these machines. For example, if I were to suppose if I were to have a 1 GB file and would like to store on Hadoop systems, after I store on Hadoop system, it will break down to 8 blocks. Every block size, one block size in Hadoop is equal to 128 MB. So that is how my data gets divided across the cluster. So to store 1 GB of data, I would be creating 8 blocks. Now all these 8 blocks, each one of these 8 blocks will be stored on a separate data servers. We have lot of data servers, and these machines are interconnected in a network. So that is how I create my cluster. When I say a cluster of commodity hardware, remember it says clusters of commodity computers. That means my common machines which I'm using in day-to-day activities, which all of us are using like laptops or desktops, they can be converted into a Hadoop cluster. So a cluster is basically nothing, a network of commodity computers put together to create a virtual single machine. What I'm doing, I'm just creating one virtual machine. So if I were to store 1 GB of data on my Hadoop cluster, I would be creating 8 blocks. Every block size would be a 128 MB. That's a default in 2.x. It's a default size, and that too is configurable. You can change it as per your requirement. When I say Hadoop 2.x, that means it's 2.x version. Currently, we are using 2.7.2. That is the latest Hadoop version available in the market, and that too it's open source. Remember, all Hadoop versions, all Hadoop products are open source from Apache. You don't have to pay anything. You just need to download. You can download from this locality from this link, and it's called apache.org. Now, the company name is Apache Software Foundation. They provide all the available Apache products, whatever about there are 40-50 products available in Apache family, and these are all open source. So all you have to just click on the link, which is the mirror link for downloading. And here you'll find all the distribution libraries available for all the products. So in case we need to download Hadoop, so we can go to Hadoop folder, click on common, and there it is, 2.7.2. That is the latest version available. And to create Hadoop, to install or configure Hadoop on your systems, please understand Hadoop is a Java based, so you need to have, if all of you are having a Windows machine, then you need to create a VM. So first you need to download a VM player, or you can download VirtualBox, Oracle VirtualBox, and then create a VM. That is basically a virtual machine, and with a different OSs, Linux based OS or Linux based OS. For example, you can have Ubuntu, or you can even have Red Hat or CentOS. These are all different flavors of Linux OS, and we need a Unix environment to work on Hadoop, and then we need to install Java, because Hadoop is written in Java. So the language which is required to run Hadoop is Java, and then finally you can install Hadoop on your systems. So this is how we need to install Hadoop, and we were talking about the storage mechanism. So storage mechanism in Hadoop is called SDFS. Remember, whatever data is processed in Hadoop systems, it needs to be first stored in Hadoop. Only then I can process the data. So it's a two-process mechanism. Please just keep your questions for the last 10 minutes. I'll be answering all of your questions. So Hadoop basically has two main components. One is storage, storing the data, and one is processing. The second one is processing the data. So we need to first store the data, and then we will be processing the data which is there in Hadoop systems. So for storage we have SDFS, that is called Hadoop Distributed File System, and processing the data we have MapReduce or Yarn. That is a mechanism which will process your data stored in SDFS. So we were talking about how the data is stored in SDFS. We have 1 GB of data. Suppose I have got 1 GB of data. I need to store it on my SDFS and process it. So once I load the data on SDFS, that is my storage mechanism of Hadoop, it would get divided into blocks. So 1 GB of data will be divided into chunks, and that is called blocks. So these blocks are being created and stored on different machines. So every block which is created for one file would be stored on each machine, and these machines are called data nodes, where the data resides. So every block here would be stored on different machines. on different data nodes. And to control these data nodes, we have a master node. So these are called slaves. These are called slaves. And to control, we have a master, which is called a name node. So name node will control all these data nodes. Remember, the data is always stored on data nodes. Name node only has the metadata. So every block which is stored on the data nodes would be having some information such as block ID, block locations for each file. In this case, if there are 8 blocks being created from 1 GB file, every block will be having its respective block ID, and every block which is located on some IP address on a different machine. Remember, all these machines will be having separate new IP addresses. They are connected on a network system, and that too in any geographical area. Need not to be only in the same premises. It can be anywhere in your geographical area. So every machine would be having a block location, specifically a IP address of that machine. So whatever, once the blocks are scattered across the network, that information is called metadata, and that data resides on name node. So whenever a user would like to read a file, the name node will be containing only the postal addresses of those blocks, the file name, the permissions, and the different other factors, along with block ID and locations for that all the blocks, and that would be read by the user, and then the user interacts with those nodes directly where the blocks are located. This is how you read a file, and this is how the files are stored or written across the network. Whenever you load a file gets divided into blocks, and these blocks are scattered across the network. Now, one more important point to understand: in case what happens, one of your data nodes or the data servers crashes down, or there is some network issues. So out of 8 blocks, 1 block will not be readable. That means my file is corrupt. If one of the part of my file is not readable, or I'm unable to process it, that means that file is corrupt. So how do Hadoop maintains the fault tolerance? That is done by creating fault tolerance is done by creating replicas of these blocks, of all the blocks. What happens in this case? By default, the replica factor is 3. That means total 24 blocks will get created. Instead of 8 blocks, 2 more blocks will be replicated. So when I say replica factor is 3, that means any block which is created in the SDFS will be having total number 3. There will be 3 copies for each block. It is 1 plus 2. If I say replica factor 1, that means there will be only 1 copy. If I say replica factor 2, 1 plus 1, that is 1 plus 1 extra copy. So in this case, by default, the system allows to create 2 more copies. So the total number of blocks is equal to 24. For this case, to store 1 GB of data, I'll be ending up using 3 GB of disk space on my cluster. Why? Because I'm having the replica factor 3. And what is cluster size? Cluster size basically is equal to total disk space for all data nodes. So when I'm saying cluster size, and I'm having cluster size of, suppose I've got 30 machines of 10 terabytes. Every machine has a capacity to hold 10 terabytes of data. So in case if I'm having 30 machines capacity of 10 terabytes per machine. So my cluster size equal to 300 terabytes. I can store 300 terabytes of data. And if my replica factor is 3, I can store actually 100 terabytes of data only. Actual data can reside on this cluster. So all of you understood this part. In case I have a 1 GB data which needs to be uploaded, I'll be ending up using 3 GB of disk space, and suppose my cluster size is, I'm having 30 machines in my cluster, and every machine has a capacity of 10 terabytes of disk space. So my cluster size becomes 30 terabytes. So the actual data which I can reside is about 100 TB of actual data can reside on my cluster. That is the actual disk space available to store the data. So it's an open source. We have seen that it's an open source data management. It's scale out. Scale out means, now what do you understand by scale out? Scale out means, suppose tomorrow if my data goes to 200 terabytes, then how do I handle that data? I'll simply add more machines or data nodes to my cluster. I don't need to replace, I don't need to add more changes to have any more changes in my structure. I simply add more data into my data nodes into my system or mechanism, and that feature is called scalability or scale out. I can simply add and create, increase my cluster as and when required. Today, in real terms, people are having a cluster size of 40,000 nodes, 50,000 nodes. That is a real practical size people are maintaining about the cluster. And then distributed processing. Now what is distributed processing? Remember, the blocks are located on different machines. Now a simple analogy I would like to give you for processing is that suppose you have a 100 man-day job in your hand, and if I give that work to, for example, 10 people, they will take 10 days to finish the project because it's a 100 man-day job. 10 people assign that project. The project can be completed into 10 days flat. Now if I want to speed up this project processing or speed up or reduce the number of days, then I have to increase the number of people on my board. So if I increase it to 40 or 50 people, for example 50, 100 man-day job, then I can finish up the entire project in 2 days. Same thing, same analogy works in Hadoop. Here what are we doing? We are not storing the data just for sake of storing it. Remember, Hadoop is not a storage mechanism. We are dividing the data so that we can process the data parallelly. Please understand this point very clearly. I am not breaking down my data just for the sake of storing it. Please understand why I am breaking the file into blocks, and those blocks are being stored on different machines. Why? The question remains why. It is only because I will process all these blocks parallelly at the same time. So the time taken to process one block or 8 blocks will be same. So I end up processing any number of blocks with the time capacity taken by one block. So if tomorrow my data increases from 1 GB to 10 GB, and if my cluster size is very good to control or hold the entire blocks on different machines provided, then the time consuming for 5 GB of data will be same as 1 GB. That is the beauty of Hadoop. You create such a cluster that as your data grows, your processing time never increases. So you have to match your cluster size accordingly so that your processing time does not increase. Why? Because the data processing is more you can say beneficiary rather than having the cost of creating a cluster. The cost of creating a cluster is one time. but the time you save in processing the data, that money or that amount of effort, or that you can say, that cannot be monetized, or that cannot be put in exact value. So that is the advantage people would like to take. They would like to reduce the processing time so they can take benefit out of the real data. Any amount of data can be processed. That is why we say we can process any amount of data in very quick time, because we can create those big clusters and we can process those blocks separately and parallelly across the cluster. That is the real magic of Hadoop. I am able to process every chunk independently and parallelly, though just like I'm just processing one file sequentially. Though all the data is not processed sequentially, because every block will be processed in a separate machine, in a separate data server. The beauty of is that we are sending the code, because once you fire a query on Hadoop systems, those query will replicate and go to every data node where the blocks are located. In this case, there are 8 blocks. So the query which you are firing from your client side, for example, if you say, I would like to find the sum of quantities sold across each item, then certainly you'll be saying select item ID, comma, sum, or quantity group by item ID. Normal select statement would be like this. So you're finding the quantity sold for each item. So that query will be passed on to every block, and how these blocks are processed, and then you get the final answer. That itself is called MapReduce or YARN architecture. And that is why we say it is distributed processing. The word distributed processing comes from here. We are able to process every block, every chunk of data independently and parallelly across the cluster. We had discussed the size of data, variety of data, and velocity of data. Data could be unstructured, structured, semi-structured. Size could be anything. Velocity could be any speed at which the data would be coming to your systems. Now Hadoop has 4 main characteristics. As we have discussed, is highly reliable. Why reliable? Because I have the replica factor replicas being created for every block. So the moment I'm not able to read a block, I can read it from the replica, which is stored on a different machine. The second case is economical. We all understand the software which is required to run these systems are open source. We can just download, install it, and configure it. Flexibility, I can run multiple processes. I can run a SQL statement, I can run a Java program, I can run a pig program, I can run a graphics program. Various programs can be run on a single framework. And the last but not the least, scalable. Scalable stands for the number of machines can be added as and when required. So I don't need to worry about the size of a cluster before I start my cluster. You can start your cluster with 2 machines, 3 machines. I've seen people creating a cluster for 3 machines. And as and when data grows, they simply keep on adding new extra data nodes to their cluster. So these are 4 important points of Hadoop architecture. And this is the Hadoop ecosystem we would be learning in the main class. The bottom layer is SDFS. That is where your data resides. So remember, your data has to be first fetched into SDFS. Only then you can process the data. Please remember this very clearly. I cannot keep my data outside of SDFS and process my data. For example, I cannot keep my data in Oracle database and run my processes in Hadoop. That is not possible. So first thing, I have to bring my data into SDFS. Only then I can write processes and produce those results. And the YARN is the framework which will run the processing mechanism of SDFS. And then we have these various tools running on top of YARN. For running a Java code, we have a MapReduce framework. People who are expert in Java can use MapReduce framework. People who are excellent in SQL, they can use Hive. So today we would be discussing about Hive. How do we use Hive to process our systems? It's very similar to your SQL. There's another way of processing data using pig commands, pig Latin. Those commands are very simple, easy to learn. We have other frameworks also, like different frameworks like Swarm, Spark, Giraffe. Giraffe is basically for having graphic processing mechanisms. And apart from there are other tools available. We also have a separate columnar database in the form of HBase. And on top of that, we have OOSI, where you can design or schedule your programs. You can schedule your process at accordingly date and time that process will run and it will fetch your results. At the bottom of SDFS, you can find two tools available in the form of Scoop and Flume. These are basically your data loading tools. If I were to load any data coming from Oracle, I would simply use Scoop to transfer all my data into SDFS without much difficulty. In case of any structured or unstructured or streaming data, I can use Flume. So these are different data loading or data ingestion tools into SDFS. Now, as we discussed that, we were talking about Hive. Hive is a data warehousing processing tool. So before I jump to Hive, let me just show you how Hadoop looks like and what is SDFS it looks like. Yeah, HBase is a part of SDFS. You can say that we store HBase data in SDFS. Unlike Cassandra and MongoDB, which are not part of SDFS. So these are all popular columnar database. Remember, our own Aadhaar card data is stored in HBase and MongoDB. So we are using a lot of Hadoop tools in storing Aadhaar card data. So I'm just launching my own VM, which is on top of my Windows. It's a VMware and then it runs Ubuntu. So I'm using Ubuntu OS. Now this would be my terminal. I will be doing my interactive commands through my terminal. So first I need to start my Hadoop services. Initially you'll be learning how to install Hadoop on your systems, and then once you install it, you need to start those services. So when I start my Hadoop services, you will find all data nodes, name node, secondary name node being started as service. And then we start yarn services. Those are basically your resource manager and node manager. So I'm starting my name node. This is basically your master node of SDFS. Then data node starts. This is where your data resides. Then we have secondary name node, which is a backup of your name node. Remember, name node becomes a single point of failure. If your name node is down, your entire cluster is down. So we need to have a backup for name node. But in 2.x, now we are having a standby name node also. So that features also we'll be learning through the course, actual course. And then now I'm starting yarn daemons. These are resource manager and node managers. If I run JPS, I can see all the services which are now on. Now, I believe all of you must be aware of Linux commands. Linux commands are very important. Suppose if I want to load a file on SDFS, I have a local file here. This is my local file. And now this is on my local file system. I want to upload this file on SDFS. First, let me delete one folder on SDFS. There is a folder status. Okay, now let me show you how the name node looks like. So this is your Hadoop systems, and the starting is root. So root is basically your starting point in HDFS, similarly to what we have in local file system or what we have in Windows also. Windows we have backslash, in Linux we have /. Now if I were to create a folder on HDFS, I would say Hadoop fs hyphus mkdir. This will create a folder on my root of HDFS by the name of Kratos. Here I'm creating a folder by the Kratos name. And if I say Kratos, okay, now you can see a folder being created, and the folder is blank. Now I'll transfer this file.txt to my HDFS. I say Hadoop fs. These are all commands, and we'll be learning all these commands through the actual course training. File name is file.txt, and the destination path is /Kratos. This will take this file to HDFS. If I refresh it, you can see the file is being uploaded. And now there is one single block, since it's a single block, a small block, and this is a block ID. So every block has a block ID. So if I load a larger file, a file which is bigger than my block size is 64 MB. I have configured it to 64. Suppose if I load a huge file, I've got a 186 MB file. I'll be loading that file. Now I'll be loading this. This file is 186 MB file, which I'm loading right now. So we create series of blocks, not one block. The file will get divided into blocks. After I refresh it, you can see the file size is 186 MB and the block size is 64. So accordingly, it will create at least 3 blocks. So you can see there are blocks 3, 0 block, block 1, block 2. The last block will be of a smaller size because it picks up the balance amount of the file. Remember, when we only define the upper limit of a block. We can have a smaller block limit also, block size also. But we are only declaring the upper limit of a block. So this is how the file gets decided and stored on HDFS. Now coming back to our processing mechanism, how we process data on Hive. Now suppose I have one file being created here. I have a nano customer data. I have a 5-column data. The first column is customer ID. Second column is first name. Then we have last name, age, and profession. It's a CSV file, a comma separated file, and it has 5 columns. First column is customer ID, first name, last name, age, and profession. Now I'll transfer this file onto HDFS. Okay. Now you can see the file has been uploaded. Now we would like to run a process on this data. I will write a query to run a process on this data. Okay. For that I need to work in Hive, and for Hive I need to enter into Hive shell. So just enter Hive, type Hive and enter into Hive mechanism, which will take you to the Hive systems. Remember, Hive is very similar to your SQL query tools or any SQL query language tools where you can write select statements, create databases. So currently I'm in a default database. If I say show databases, it will show me all the databases here. So let me create one database, create database Kratos. And I say use Kratos. Now I'm in a Kratos folder or database. Okay, now I need to first now create a table here. So I'll be creating a table and then loading the data. Now this is a command to create a table, create table name, and define the column names with the data types. Then we have the row format, which is delimited, and I'm using comma as a separator, and my data would be stored as a flat file on SDFS. So now if I say show tables, the table is being created. I can also say describe customer. It will give me all the column names and the data types. Now I would like to load the data into this table. Now I'll be using my load data in path. So I'll be calling the data from Kratos. So just changing the path here. So I say load data in path. Remember the file was under Kratos and I'm passing the data into customer table. If I say select star from customer, see now the data has been loaded. I can see all the records in a structured way. Remember the data is still unstructured as a flat file, but Hive allows me to read the data in a structured mechanism, and now I can write different queries using the select statements. For example, I can write select. Let me see the schema first. Describe customer. Okay, now if I'd like to know the count of each profession here, so I will say select profession, comma, I can say select profession, from customer, group by now it's been converted into a series of mapped jobs in Java based and get the results for us. So you can see how many writers, how many pilots, how many judges we have. So there are 83 people who are not having any professions. These are blanks. There are 197 accountants, 196 actors, 195 agricultural food scientists, architects there are 202. So that is how I'm able to process my data using select statements. So these all can be done. These are all different processes which you can do it. I can also write different queries here which will allow me to process my data. So this is how you process your data in Hadoop systems. So initially Hive was started by Facebook, and the data growth was very exponential in those days, and it required a very fast mechanism by which they could process the data. So Hive is a data warehouse infrastructure tool to process structured data in Hadoop. Basically your data resides in an unstructured way, but you are able to process in a structured mechanism. It resides on top of Hadoop to summarize big data and makes querying and analyzing easy. It provides Hive query language which is very similar to SQL. We just saw that we could write SQL select statements in Hive, and it converts your SQL queries. But please understand, SDFS does not understand SQL queries. So there is a mechanism, a compiler in between, which converts your select statements into Java-based MapReduce jobs, and that job will run on your SDFS. How the Hive mechanism works, it's another story. The database, it has a structural part which is stored in a database. It has an embedded database. The data which is there is stored as a flat file. So whatever data we are storing, it ultimately it is stored as a flat file. It is not designed for OLTPs. I cannot do row level updates like I can do in databases. I cannot run an update command or a delete command. Either I can append data or I can overwrite the data. That is a drawback in Hive. And it provides a SQL type language for querying SQL. It's familiar. It's very familiar. Like we all understand SQL queries, fast, scalable, and extensible. As we have worked on SQL statements, we can do a lot of data mining, log processing, business intelligence, and predictive modeling. So it can be used anywhere, since we all understand SQL statements, the power of SQL. So if I were to describe Hive in one line, I would say Hive is equal to Hadoop plus SQL, because it is using the power of parallel processing Hadoop and power of SQL statements. A small comparison between Pig and Hive, since if anybody understands Pig, it's good for them. Pig is basically a procedural language. Hive is more declarative, and Hive is basically used for data analyst, and I can also create partitions in Hive, which is not possible in Pig. And these are the 5 main components of Hive. We have an interactive shell. We just worked on that shell commands. And it also has a meta store, which is storing all your metadata. That is a structural part. So whenever I create a table, that table gets stored in meta store. Then we have an execution engine which will convert, which will talk to SDFS or Yarn. And we have a compiler which will convert your code, your SQL code into Java-based MapReduce code, and the driver will run the program for Hive. This is the overall architecture of Hive. We have interactive JDBC connectivity. We can have a remote thrift server by which you can access Hive, and we can also create user-defined functions in Java. Through that also we can access Hive. And the formats, the database storage could be a text file, a sequence file, or an RC file. These are certain commands available, and I believe all these commands are very similar to your database commands. To create a database, you will say create database, database name, Dropping is easy. Drop database name, create table name. Need any alterations, we can use alter command, drop table for deleting a table or dropping a table, insert values, and then finally running select statements to view the table contents. So demo part, we already gone through it. Now let us go through all of your questions, if in case you have any. Yeah, Vijay, we have Cassandra as a suitable OLTP database for Hadoop. So in case you want to use any OLTP databases, you can use Cassandra. No, Sushma, there is logic. There are two types of division. One is logical division, that those are called input splits, and the other part is called your blocks, which are physical division. So whenever the data is read, data is always read through a logical division. So a very good question asked by Sushma, that is there any logic considered while dividing the data into blocks? Reshma, you can use different scripts in the Hive. I can create scripts like PLSQL, but unlike PLSQL, you cannot declare variables. It does not allow you to declare variables and assign variables. You can write different statements into one script and use them. 2.x Mahesh, the size of the block is 128, and we can go it. Veera, certainly we can adjust it to any size. Puneet, currently I'm using, it's a single node machine. That's why everything is on one machine itself. But it gets the result in seconds. So it's little slower than the Java because it has to first compile the code. So normally Hive is not used for smaller data sets because the compiling of code will take equal time, whether you're running on 1 MB data or 1 petabyte of data. So that minimum time is consumed by the code itself just to compile it. So that's why you feel that you're running on a smaller code, less amount of data, so it's taking more time. But if I were to run the same code on 1 petabyte data, the compiler would have taken the same time to convert the code into Java-based MapReduce job. Yeah, Ashwani, really, I'm not able to understand your question. Ashwani, can you just repeat the question? Vijay is asking, how can I migrate one Hive? There are disk cp command, so you can just use it, disk cp command to transfer the data from one cluster to the other cluster. Remember, the data is still in the format of flat file. Yeah, replica factor by default it is 3. I can also set it at the file level. So depends upon your requirement. So there are two ways of setting up your replica factor, Mahesh. In case you're setting a replica factor 2, then certainly both those blocks will be on separate machines. Chandan, what about the memory architecture? Memory, basically your data resides on disk, and that part is covered in your yarn where your data is processed in memory in containers. So that is basically the yarn architecture we would be talking about. No, it's a pipeline of replicas, Eben. So whenever you are writing a block by block, normally we write block by block on the system. Suppose I'm writing a file, so we first write first block, and then we'll create the replicas immediately by pipeline of data nodes. So the data node will create replica on a different data node first, and then the second block is written. After the first block is acknowledged in totality, only then the second block is written. Chandan, security-wise, we are having two layers of security. One is your own Unix layer, plus we also have we can also install third-party Kerberos tool. So that is a very, very efficient security mechanism. Mahesh, can your database process data? Can your data process 1 GB? How much time does it take to process 1 GB of data? Or about 200 GB of data? That will take very much time when you have traditional systems. I cannot divide the data into blocks and processing it straight away. Reshma, in that question I cannot help you. You have to first take formal training and then you can learn it on through internet. No, Ashwini, Java is an optional. People from SQL background are entering into big data platforms. But if you learn Java, nothing bad in it. There is nothing wrong in learning a language. Yeah, we can create joins and we can also have indexes, primary indexes, just like your database. Global standard certifications are like from Cloudera and Hortonworks and from MapR. Yeah, we have to distribute cache concept here, Chandan. So a lot of data can be pulled into cache and then we can share it across the cluster. Mahesh, if you have some structured data in different text files, you can pull all that data in one folder and give the path to that folder. So you pick up all the data in one go. So if you are taking the class, the real class, we would be going through all the practicals. Vijay, there are various tools available. Hive is there, Pig is there. Pig is also a very interesting tool. Once you learn Pig, it's very easy to use and very easy to learn. If you're a Linux admin, Srikanth, I advise you to go for Hadoop admin because there are a lot of opportunities for Hadoop admin also. And since you are from administrator background, you'll be able to catch up the admin part very easily. And there's also a very huge requirement for Hadoop admin guys. No, Madhav, the data is always read from the nearest port and due to bandwidth issues, so that is done by the framework. Yeah, you can load through various tools available. I believe Informatica allows you to load data in Hadoop. So you can access Hadoop using ETL tools. And there are various tools available. For that, you need to get in touch with the support staff, Srikanth, for Hadoop admin course. And even there are a lot of tools available by which you can access HDFS and you can dump in your data. Certainly, Mahesh, if you have a good eye for data and you have a good SQL background, then this course is right for you. This course is in fact perfect for you. So you can easily catch up all the things in a much easier way. And I would say that you should stick to Pig and Hive, which are much more in demand because it takes very less time to code. So the idea basic behind the Hadoop is not to spend time on coding. You should be spending more time on logical thinking because the data is there. You need to find mechanisms or write codes where you can write hundreds of queries in quick time. Remember, Facebook generates 75,000 queries every day. So there are requirements for people who can write huge number of queries in minutes and get the results. So that is why these tools are available where you can process the data. One has to use an agile method, not a different method where you can just write a query, get the results, and then move on. Predictive analysis will come after you when you process your data using R technology. So the data coming from big data results can be combined with R and can give you results out of that. Eben, then certainly you're dealing with data, then developer tool will be more better for you. Since you have 3 years of experience in SQL, I believe you should go for developer course. Reshma. So let me just go through the course content before I take up more questions. This course is for developer. This demo is for developer. So these are the course curriculum. The first session we'll be talking about detail in big data and Hadoop. In class 2, session 2, we'll be talking about the architecture of SDFS, the configurations, how do we install Hadoop on systems, and how do we load data from various mechanisms into Hadoop. Then the third will be about MapReduce, the third and fourth class, which is the processing mechanism. In the class 5th and 6th, we will talk about Pig and Hive, and 7th, more Hive advanced concepts. Class 8 will be about HBase, that is the columnar database. 9 will be about Uzi, and finally in the 10th class, we'll be discussing about the projects. How do we initiate live projects, and we'll be solving one of those projects there. Reshma, for that you can get in touch with the HBase does not have its own query language. It's a very small, like, scan command and all that. You can use various tools to access data in HBase. It does not have its own query language. I can use Hive to correlate my data and process my data in HBase. I can pull my data into HBase, from HBase into my Hive tables. And Kratos gives you a lot of help as far as support is concerned, and we give always 100% placement assistance, so we help you out to get a good job. And please note that there are a lot of requirements for developers, and you also get lifetime access to the course content via LMS. So whatever updates are happening on LMS, you can access those contents through lifetime. And these are some of the corporate partners we are engaged with, and we would be placing, once we complete the course, certainly the interview will be lined up with all these companies. Both are good for predictive analysis, though I have very little knowledge on SAS, but I know R is used for predictive analysis. And you can also log on to our website on kratos.com. And if you want to reach us at sales@kratos or brajesh@kratos.com. These are the numbers you can reach us directly. If you guys are calling from US, then you can just log on to your toll-free number 646-362-6476. If anybody calling from India, you can just dial in 702-255-1245. And in case you need to know more about other courses, then you can just log on to Kratos. This will give you a better idea about what does company, what more we are offering. Yes, we provide certification, so certainly the certificate will be provided by the company. Yes, certainly the slides will be shared with you, Sushma. You can get in touch with the support staff. It's taking time because I know why. Shadow side is not working now. Maybe there's some network issues on my PC. That is the reason I'm not able to view the site. So currently they are offering 4 courses Java, they are offering Python courses, and they are offering Hadoop courses plus one more course they are offering. So you can just first try for BigData Hadoop developer course. There it is. They are also offering your R course, R programming. These are some of the very popular courses. And I'll pass on the baton to Brajesh. He'll take care of the entire and he'll discuss the following things with you. Thank all of you for joining this webinar session. So I'll be taking a leave and now I'll be passing on the baton to Brajesh. Thank you all of you. Thanks a lot once again. Thank you. Bye-bye. Take care.